Then only that. Then let's say this is a conductor. Right. Right here. Right here. Let's say this is a conductor. Let's say this is a conductor. This is a conductor. Conductor. Right. And this conductor carries a current. Carries a current capital I. Right. If it carries a current capital I like this in this direction, we know the respective electron flows in the opposite direction. Respective electrons flow is in the opposite direction. Electron flow. Then the electrons flow in this direction like this. Electrons flow in this direction like this. Right, the current flows to the leftward direction. The current flows to the leftward direction. Electrons flow in the opposite direction. Right. Now, let's say this conductor is kept in the magnetic field of cross. This conductor is kept in the magnetic field. Right. This conductor is kept in the magnetic field cross. This conductor is kept in the magnetic field B cross. Right. So we know electrons are charges. Electrons are charges. Right? When a charge travels through a magnetic field, it creates forces. When a charge travels through a magnetic field, it creates forces. Right now, on these electrons, there are forces created due to magnetic field. On the electrons, there are forces created due to magnetic field. Right? Check the reaction. Electron is a negative charge. Then current carries in the opposite direction. Direction of current is leftwards. And direction of magnetic field cross. Direction of magnetic field is cross. Direction of current is leftwards. Then direction of force is downwards. Direction of force is downwards. Which means on an electron, there is a force due to magnetic field acting downwards. Let's say if we force due to magnetic field, right? That is acting downwards. Now there are a massive number of electrons are passing through, right? And on each and every electron, there is this force that is acting due to magnetic field acting downwards, right? Now, likewise on each electron, this force Fb acts downwards, right? Now, when electrons flow in this direction, there is a force due to magnetic field acting downwards, right? Because of that, their motion is deviated. And now, what happens is these electrons are deviated. In this direction because of this force. Right? Now these electrons are deviated like this because of this force. And now what happens is when current flows continuously, right? When current keeps on flowing, right? After some time, now electrons are reaching the bottom surface. They are reaching towards the bottom surface. So after some time, right? Electron density at the bottom surface is higher. It's greater than the top surface because all electrons which are passing through are reaching the bottom surface now. Right? Now after some time, because of the higher electron density at the bottom surface, this bottom surface takes a negative charge. Right? Because of the higher electron density, the bottom surface takes a negative charge. Then with respect to the bottom surface, the top surface takes a positive charge. Because with respect to the negatively charged bottom surface, top surface now is positively charged. Right? Then with respect to this top surface is now positively charged. Top surface is positively charged. Right? Now the thing is this. We have a gap between these two ends in this conductor, and this side is negatively charged, the other side is positively charged. Right? Which means they are two different potentials. Means, right? Two different potentials means now they have a potential difference in between. Right? There's a potential difference, right? In the distance we know, it is going to create an electric field, right? Because E equals delta E over D. If there is a potential difference, right, there's T, there is an electric field. Electric field acts from high potential to low potential. Then from plus to minus, high potential to low potential. What happens is now all of a sudden after this, an electric field generates like this. Say capitally. Right? Now all of a sudden, as a result of this, otherwise there was no electric field given to the system initially. As a result of this, now there is an electric field generated. Right? That is generated like this. It is generated. Right? Now here is the reading arms. Now what happens is, for the electrons which are passing through, now other than the magnetic field, now it has an electric field as well through this same surface, right? Through this space, now it has a electric field as well. And we know electric fields also create forces on charges. Electric fields also create forces on charges, right? Then what happens is, on these charges, now electric field is also going to generate forces, right? On negative charges, we know, on negative charges, direction of force due to electric field is opposite to the direction of electric field. On negative charges, direction of force due to electric field is opposite to the direction of electric field. Now electric field is downwards. Electrons are negative charges. Then force due to electric field is opposite to the direction of electric field. It should be upwards then. Then on each electron, then the force due to electric field, say Fe generates like this. Fe generates like this. Right? Now on each electron which travels through the surface, right, which goes through the surface, now it has two forces acting on. Fb is due to magnetic field and Fe is due to electric field. Right? And when this keeps happening, when potential difference increases, when P increases, and in this system, there are some point it reaches, right? There are some point it reaches when Fp equals Fe, because Fe's keep increasing because of the increasing potential difference, right? Fe is keep increasing. Then at some point, right? Don't write this part. I'm just showing you, right? At some point, Fp becomes equals to Fe, right? Fp becomes equals to Fe at a point, right? At that point, what happens is, since forces are equal, there is no vertical resultant force. There is no vertical unbalanced force remaining on the charge. If there is no vertical unbalanced force, now amid the impact of both forces, the charge again travels in a exactly horizontal straight path, because Fp equals Fe. And then it travels again in a straight path, right? This point or this phenomenon is called Hall effect. This point or this phenomenon is called Hall effect. Right? This was found by the scientist called Hall. Right? That's why it's called the Hall effect. Right? Now, at Hall effect, what happens is, at Hall effect, Fp equals Fp, we know Fp can be expanded as, let's say, speed of an electron is u, then this is b cube v, it should be then be u if charge of an electron is e, right? Because Fp equals b cube v and Fe is given by, right, qe. But we know E equals delta VOD, right? Now the potential difference created between this surface, right? This is called the whole voltage VH, right? That is called the whole voltage VH, right? And let's say the gap here, thickness here is the, right? Now E to E cancels, then VO equals E is delta VOD, delta V is VH in whole effect, right? Over T. And it gives VH equals VUD. VH equals VUD. This is called the equation of Hall effect. Right? For this, we say this VH equals but, right? Power is we call this VH equals but. Equation of Hall effect. VH equals but. Right? The beauty here is there was no electric field initially, right? Because of the magnetic field or the force due to magnetic field, electric field generated as a result, right? So this is basically what is happening in Hall effect. We'll explain this in detail. Raise your hand if you got this idea. Raise your hand if you got the idea. And Ask if any questions also. Is it clear or not clear? I can quickly explain again if that is not clear. So, what about it? Tell me quickly. Is it clear now? Right. We'll explain again. We'll explain again. First, take down the diagram and mark everything here. First, take down the diagram. Then, after the explanation here, I'll explain again. Right? Because I want to explain again in the note also. Right. Take down the diagram and if you are using different colors, use colors and have a clear diagram. Huh? Have a clear diagram. Okay. Right. Listen again. So, this is what is happening here. Listen again. Listen again. Now, electrons are flowing through the conductor, right? When it flows through the conductor is kept in a magnetic field of B. Now, if this is an electron, right? If this is an electron, right? When this electron goes through the conductor, right? When this electron goes through the conductor, now here for the conductor, cross magnetic field is given, right? A cross magnetic field is given. Because of this cross magnetic field, right? Because of this cross magnetic field of the conductor, right? This gets a force. Exerts a force. Right? Force is given by the means left hand rule. Right? Direction of B is cross. Right? And direction of current is opposite direction of motion of the negative charge. Right? Direction of current is this. Right? Here the this. Then direction of force is downwards. Direction of force is downwards. Right? That is the force I referred as FB. Force due to magnetic field. FB. Right? And because of this FB, electrons are reaching towards the bottom surface. Right? Because when it travels forward, now it has got another force acting downwards, right? Because of that force, each and every electron which passes through here gets this force, and they are reaching towards the bottom. Then after current flows for some time, then bottom surface gets a negative charge because of the higher density of electrons, right? It gets a negative charge because of the higher density of electrons. Then when it is negatively charged, then top surface is positively charged comparatively compared to the negative surface is positively charged. Right? So when there is positively charged, now this is what happens. So now after this is negatively charged, it's become positive comparatively. Right? When there is positively charged, now between these two surfaces, now it has got a potential difference. Because of the potential difference, it creates an electric field again. It creates an electric field again. That is an electric field again. An electric field. Now, since there is an electric field, for all the new electrons which are going through now, right? For all new electrons, right? Current is continuously flowing. When current flows, electrons are coming and electrons keep on coming. Right? Electrons keep on coming. Then on the new electrons, now there are two fields. Since there are two fields, one force is due to magnetic field that is FB acting downwards as this, and because of the electric field, right? There is another force due to electric field acting upwards because direction of force due to electric fields on negative charges is opposite to direction of electric field. Then since electric field is downwards, force due to electric field is acting upwards. Right? At the point where these two are equal, this is going to travel without no deflection. Right? At the point where these two are equal, this is going to travel with no deviation, no deflection, right? Just on a straight line. That point is called Hall's effect. That point is called Hall effect, and that point is right. That point is what I figured out here. And since P equals Fp at that point, we proved the equation using that logic. Right. So at Hall effect, once the whole voltage is reached, at the Hall effect, there's no deviation again. There's no deviation again. Right. Then it travels. All the new electrons travel without any deviation. Right. This is a phenomenon. This phenomenon is called Hall effect. Right. Raise your hand now if clear enough for ask if any more questions. Okay, mention below First point. Then mention below. First point. Mention below. First point. When current flows. When current flows. When current flows. When current flows. The respective electrons. When current flows. The respective electrons. The respective electrons. When current flows. The respective electrons. The respective electrons flow. The respective electrons flow in the opposite direction. The respective electrons flow in the opposite direction. Respective electrons flow in the opposite direction. Alright, next point. Next point. When electrons pass the region, section. When electrons pass the 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 section with magnetic field. When electrons pass the section with magnetic field. When electrons pass the section with magnetic field. It generates a downward force. It generates a downward force. It generates a downward force. According to a downward force according to Fleming's left-hand rule. A downward force according to Fleming's left-hand rule. A downward force according to Fleming's left-hand rule. Due to magnetic field. Within brackets FB. Like this. Within brackets FB. Like this FB. Within brackets FB. Right, next point. The path of electrons deviates. The path of electrons deviates. Towards bottom surface. An electron density around bottom surface. An electron density around bottom surface. Increases. Electron density around bottom surface increases as a result. Electron density around bottom surface increases as a result. Next point. Therefore, the bottom surface gets a negative charge. Therefore, the bottom surface gets a negative charge. And comparatively, top surface gets a positive charge. Right? A positive charge gets a positive charge. Right. Next point. Next point. Point. Hence, a potential difference. Hence, a potential difference. Hence, a potential difference. A potential difference is created between. Hence, a potential difference is created between. Hence, a potential difference is created between. A potential difference is created between top and bottom surfaces. Created between top and bottom. Created between top and bottom surfaces. Created between top and bottom surfaces. Between top and bottom surfaces. And it creates, and it creates, and it creates, and it creates an electric field, and it creates an electric field, and it creates an electric field. It creates an electric field from higher potential to lower potential. 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 Within brackets, plus to minus. Within brackets, plus to minus. Within brackets, plus to minus. And next point. Next point. Now, 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 another force. Now, another force. Another force. Due to electric field. Now, another force due to electric field. Another force due to electric field. Now, another force due to electric field is created on. Is created on. Is created on electrons. Is created on electrons. Is created on electrons. Pass by. Electrons pass by. Electrons pass by. Next point. Next point. And for the above point, within brackets mention Fp. For the above point, within brackets mention this Fp. Positive electric field. Within brackets mention Fp. Fp for the above point. For the above point. Right. Then next point. Next point. When Fp equals Fe. 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 There's no vertical resultant remains. There's no vertical resultant force remains. There's no vertical resultant force remains on electrons. 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 For the same point, hence it travels in a straight line. 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 In a straight line. Without deviating. Hence it travels in a straight line without deviating. It travels in a straight line without deviating. Hence it travels in a straight line without deviating. Hence it travels in a straight line without deviating. Without deviating. In a straight line without deviating. Next point. Next point. This phenomenon occurs under. 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 Impact from. This phenomenon occurs under impact from magnetic field and electric field. Under impact from magnetic field and electric field. Under impact from magnetic field and electric field is called Hall effect. 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 And the potential difference created. And the potential difference created. And the potential difference created. And the potential difference created is called. And the potential difference created is called. And the potential difference created is called Hall voltage. And the potential difference created is called Hall voltage. Within brackets VH, like this. Is called Hall voltage within brackets VH. Is called Hall voltage. Hall voltage. Hall voltage within brackets VH. Hall voltage within brackets VH. Right. Now, listen. Now, you are to take down from here and only get this thing, right? And draw this diagram also. Draw the diagram. Draw the diagram. Listen. Draw the diagram and write as at the only get and prove the equation. And prove the equation. And after proving, will be introducing terms. After proving, we'll be introducing terms. Right. Prove it. Okay. Right. Then introduce terms. VH Hall voltage. VH Hall voltage. Introduce terms. VH Hall voltage. VH Hall voltage. B. Magnetic flux density. Our usual term. B. Magnetic flux density. Magnetic flux density. U. Speed slash drift velocity. Speed slash drift velocity. Speed slash drift velocity. Speed slash drift velocity of electrons. Speed slash drift velocity of electrons. Drift velocity of electrons. Then D gap between Hall voltage. D gap between Hall voltage. Gap between Hall voltage. Gap between Hall voltage. Fine. So for this we keep the equation as VH equals but. VH equals but. Right? Okay. That's it. That's it. So that's everything. That's everything. Right? That's everything. Right. Anything else? Anything else? No? Anything else? All clear? Right. This phenomenon, this effect is called Hall effect. Right. So that is the 100% of 100% completion, 100% of magnetic fields. Right. Any questions?